Good morning, everyone. Good day, everyone. The topic now is very interesting. Why? Because we're going to learn about those nutrients needed by plants in general. After this lesson, you are expected to define and enumerate various essential elements. You have to differentiate and enumerate the macro and micronutrients, and you have to list down or enumerate the three criteria of essentiality, and you have to be familiar and learn the ionic form of each nutrient. Among the elements seen in the periodic table, in which I am very much sure that you are familiar with the periodic table, in which periodic table contains many elements in there. But how many are essential? What does it mean when we say essential? And what are the reasons to consider for the element to become essential? As we go along with the discussion, you will learn the answers of these questions seen in the screen. First, let's be familiar with the term essential element. Essential element is a term often used to identify a plant nutrient. The term nutrient itself implies essentiality, so therefore it is redundant if we call these elements essential nutrients. So we just have to use nutrient or essential element, not anymore essential nutrient. So please take note of that. Based on the criteria, there are 17 elements that have been considered essential. This includes 9 macronutrients and 8 micronutrients. Before enumerating the macro and micronutrients, let's first be familiar of what does it mean when we say macronutrients and micronutrients. When we say macronutrients, this refers to the nutrients that are taken by plants in relatively large quantities, while micronutrients are those nutrients that are taken in relatively smaller amounts. So therefore, the difference between macro and micronutrients is based on the amount of quantity that are taken up by plants. Okay, from the word macro, large quantity, micro, smaller quantity. Okay, now let's enumerate and be familiar with the macro and micronutrients. The macronutrients are C, carbon, H, hydrogen, O, oxygen, N, nitrogen, P, phosphorus, K, potassium, Ca, calcium, Mg, magnesium, and the last one is S, which is sulfur. The 8 micronutrients are F is for iron, Cu is copper, Zn, zinc, Mn, manganese, Mo, molybdenum, B, boron, Cl, chlorine, and the last one is Ni, which is nickel. Now, what are the sources of those nutrients? The C, H, and O, or carbon, hydrogen, and oxygen, are incorporated into the plant during photosynthesis. And the main source of C, H, and O are atmosphere, and water. The 14 essential elements, basically, most of the essential elements, the source is soil. We have what we call mineral nutrients. The mineral nutrients are phosphorus, calcium, potassium, magnesium, sulfur, iron, copper, zinc, manganese, molybdenum, boron, chlorine, and nickel. They are considered mineral nutrients. It's because these nutrients are absorbed from the soil, which means that one of the sources of these nutrients are soil. They can be absorbed, or yes, they can be absorbed by plant roots from the soil. Remember the previous discussion one component of the soil is what we call inorganic matter or mineral matter, in which it composed of minerals and rocks, and they are considered as source of plant nutrients. I hope you still remember that discussion. So that is why they are called as mineral nutrients. Next, the last essential is nitrogen. Nitrogen is very unique. Okay, its main source is leguminous crops. Nitrogen is incorporated into the plant during its biological fixation, which they are found in root nodules of legumes. When we say legumes, these are the pod-bearing plants. Example are peanut and beans. So during biological fixation, the nitrogen is being fixed. That is why the one source of nitrogen is this one from the leguminous crops. Although the source of nitrogen also is some are in the soil, but major source is they are in leguminous crops. Okay, let's now move on the criteria of essentiality. It is in year 1939 that these two scientists, Daniel Arnon and Perry Stout, made an important contribution in the study of mineral nutrition. It's because they are the one who introduced the concept of essentiality of elements. And according to them, based on the result of their studies, of their research, an element is considered essential if it satisfies all the criteria. We have three criteria of essentiality. First, there is a positive requirement of the element for normal growth or reproduction or to complete the plant's life cycle. So it means that that element must be contributor or directly involved, or they have its function that will complete the life cycle of plant, wherein if that element is absent, therefore the plant life cycle is affected and maybe it will not be complete or it will be die. So yes, that element must be have a contribution that will complete the plant's life cycle. Second, the function of the element cannot be replaced by another, meaning the function of such one element will not be substituted by the other element. Its function, they are the one that can work on or that can perform with that function. What I am trying to say is, example, nitrogen. The nitrogen has its specific function, and the function of that nitrogen cannot be replaced or cannot be substituted with phosphorus, because phosphorus has its own function and they cannot work with the function of the nitrogen. So the function of each nutrient cannot be substituted with the other. So if that nutrient is deficient and cannot perform with a function that is very much important with the plant life cycle or the plant processes, so therefore the growth of the plant is affected. Okay, the function of that element cannot be corrected, cannot be substituted, cannot be performed with another element. So that is. Third one is the element has direct or indirect function in terms of plant metabolism. So these are the three criteria of essentiality. Again, there is a positive requirement of the element for the normal growth or it is needed to complete plant life cycle. Second, the function of the element cannot be replaced by another, cannot be substituted by another element. The third one is that element has direct or indirect function in terms of plant metabolism. Okay, what about those other elements that were not considered essential element, but they have their own relative or important function in the plant? Okay, yes, there are some elements that stimulate growth. They contributed, they have their own function, but did not fulfill Arnold and Stout's criteria for essentiality. So those nutrients are not considered essential element, but they are named as or called as beneficial nutrients. So they are beneficial nutrients because they are just essential only for certain plant roots or group of plants, not in all general, just like the three criteria of essentiality. Beneficial nutrients are cobalt, sodium, silicon, aluminum, selenium, and vanadium. The essential elements were not accepted as essential or become an essential element nang sabay-sabay, like in just 1 year. The first element that were considered essential and it is a micronutrient is nitrogen, which is in year 1804. I think this is because of the major function of the nitrogen in the plant growth. The macronutrients year of essentiality was from 1804 until 1866. These are the nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. The micronutrients, starting from iron, the manganese, copper, boron, zinc, molybdenum, chlorine, nickel, they were accepted as essential from year 1922 to 1987. So the latest essential element was in year 1987 and it is nickel. In case you have already read a book or other reading material that listed only 16 essential elements, that book were published earlier than in year 1987, in which nickel were not yet included. Okay, so take note of their essentiality, and the latest essential micronutrient is nickel. We were not yet sure if some nutrient will be added, or maybe there is another scientist that will discover about it, and it will be proven through their researchers or studies. But as of now, there are only 17 essential nutrients, and the latest one was in year 1987, and it is nickel. Okay, please observe and be familiar with the table. These are the ionic form of each nutrient. Why we should know the ionic form of each nutrient? Why care about it? What is the importance of knowing the ionic form of each nutrient? Okay, take note class, the nutrient can be present in the soil, but the plants cannot absorb or use it because it's not in their ionic form, which means they can't be absorbed by plants. But if they are in ionic form, the plant roots can use it, can absorb, and it enters in the plant system because they are in its ionic form. So that is why we must be familiar with the ionic form, which is absorbed by plants. That is the form that can be absorbed or used by plants, because that is that in that way we can understand now how the soil how the nutrients is being absorbed by. For example, there is calcium carbonate compound in the soil. It is in CaCO3 compound. The chemical formula CaCO3. So in that case, calcium will not be absorbed by plants because it is not in Ce2+.